Welcome back to the Deep Dive. Today, we're sort of boarding Starship, conceptually at least, and setting course for Mars. We're digging into maybe the most sci-fi goal out there right now. Autonomous androids. Specifically Tesla's Optimus. Getting a Mars colony started. Elon Musk talks about this a lot, right? Expanding consciousness to the stars. And he actually said Optimus bots will be on Starship to Mars by the end of 2026, which is, wow, less than 3 years? These robots are supposed to be exploring Mars, building things?
It's a phenomenal vision, no doubt. It grabs you. But when you look at the actual engineering, the nuts and bolts, well, there's a big clash. We've been looking at analysis from Christian Hubicki. He leads the Optimal Robotics Lab at Florida State, and he's really, really skeptical. Hubicki knows bipedal robots inside out, and basically, he sees it ending badly. He warned that if you send these advanced humanoids to Mars all by themselves, they'll pretty quickly just become dead husks, or as he put it, scrap metal and plastic.
Wow, dead husks. That's quite a forecast for the supposed saviors of humanity's future. Okay, so our mission today is to get past the headlines and figure out why. Why does a top robotics expert see Optimus feeling so spectacularly on Mars? We need to look at the real issues. Reliability, actual autonomy, and, the nightmare logistics of fixing things from another planet. All right, let's start with that skepticism, the timeline versus where the tech actually is. Musk's schedule is just incredibly fast. Uncrewed flights in maybe 3.5 years, people going maybe 2 years later, a whole self-sustaining city in 20 or 30 years, and all of this seems to depend on Optimus working perfectly, like right away.
Exactly. And that whole rapid schedule, it's built on tech that's, well, shaky right now. Hubicki's main point, and we see this in the sources, isn't about Mars dust or radiation specifically. It's much more basic physics, really. He just says humanoids fall down, they break, their code crashes. Simple as that. It's worth remembering why walking on 2 legs is so hard for a machine. You've got dozens of joints, complex balancing acts, code that needs constant tweaking. Here on Earth, if a robot stumbles, okay, maybe it's a dent. On Mars, lower gravity, sure, but the ground is sharp, dusty. A fall could easily mean a cracked shell, a jammed joint, a busted sensor, that reliability gap. It's not small, it's massive.
And this skepticism really ties into Tesla's whole strategy, doesn't it? They're putting all their chips on AI and robotics. Musk keeps talking about this huge future valuation, trillions, tied directly to robotaxis and Optimus being mass-produced. But look at robotaxis. Autonomous driving still needs safety drivers, even on predictable roads here. So, yeah, the big question is, how can we expect a way more complex humanoid robot to work reliably, totally alone in a place like Mars, which is anything but predictable?
That's the key technical jump, isn't it? If your system needs a human babysitter in a controlled setting, expecting it to suddenly manage complete autonomy on a different planet, that's a huge leap of faith. And honestly, the Optimus demos we've seen don't exactly inspire confidence. The sources point to recent videos, and they were described as laughably limited. The robot took ages, like painfully long, to answer simple questions. It apparently glitched out mid-sentence. And the walking was still pretty clunky. And this is the machine they're promising will be building stuff on Mars by 2026. The sources are pretty clear. The hurdles for truly reliable walking robots are still enormous, way beyond what anyone's showing right now.
Okay, this is where comparing it to robots already in space becomes really important, because it highlights the one thing Mars doesn't have: humans nearby. NASA and others have used humanoids in space, right? On the International Space Station, the ISS. And you might think, see, it works in space. But that leads right into Hubicki's critical point. The massive difference between mission control being a few hundred miles up versus, well, potentially hundreds of millions of miles away.
Yeah, location changes everything. The sources emphasize that robots like NASA's Robonaut were only on the ISS. And the ISS, while remote from Earth, is basically designed for human support. Think about it. If Robonaut had an issue, human astronauts were literally already there to fix it. They could power it down, swap a battery, check a wire, upload a software patch, immediately. Or it could be remote controlled from Earth, but if the signal dropped or the software froze, a human was right there, seconds away. The whole risk calculation is completely different.
Right. And what happens when you take away that human safety net? When help isn't seconds away, but 20 minutes minimum just for a signal to travel one way?
That's the kicker. That's what turns a small technical glitch, something you could fix on the ISS, into a total mission failure on Mars. Hubicki's point. On Mars, there are no humans to rescue it, and replacement parts are a nightmare to ship in. Let's unpack that nightmare a bit. First, the time lag. Light speed delay between Earth and Mars is 4 to 24 minutes each way. You just can't remote control a robot in real time like that. It has to be fully autonomous. Second, the parts. A complex humanoid needs thousands of bits and pieces, actuators, sensors, coolers, chips. If one little $50 part breaks, you probably can't 3D print a perfect replacement easily on Mars, and you definitely can't wait, what, 7 to 9 months for the next supply ship from Earth?
So it's not just if it breaks down, which seems likely for a humanoid anyway. It's that there's basically zero chance of recovery once it does. A single jammed joint could just render it useless forever.
Precisely. And this forces us to think about self-repair much, much earlier. Let's say Optimus has even a tiny, like 1% chance of a mechanical failure each week, and that feels optimistic for a walking robot in Martian dust. Well, then it needs abilities we don't even have reliably on Earth yet. It needs to diagnose itself instantly at a high level. And then this is a huge part. It needs to fix itself or swap out modules using whatever's there.
And we're not just talking about rebooting the software. We're talking like material science, maybe tiny manufacturing capabilities, manipulating tools to fix its own body. That's a whole different ball game than just making it walk a bit better. Okay, so if the current humanoid designs are just too risky, too fragile for Mars right now, the experts do suggest other paths. What are the sort of more achievable steps or different designs they point to for space?
Well, Hubicki, thinking practically, suggests the moon first. Makes sense, right? The moon's way closer. Communication lag is seconds, not minutes. It lets the robots, as he puts it, at least cut their teeth in vacuum and low gravity before trying the Mars giant leap. Basically, if you can't make it work reliably on the moon, Mars is definitely out. It's just sensible risk reduction. You demonstrate reliability in tougher and tougher places, but ones you can still manage somewhat.
That absolutely makes sense, yeah, step by step. But there's also the bigger question about the form itself. Why are we so fixated on making it look human for an alien world anyway? Isn't the whole point of robots to do things humans can't?
Exactly. The sources really drive this home. The human body is optimized for Earth. Our gravity, our air pressure, walking efficiently on relatively flat ground. It's definitely not optimized for scrambling up crater walls or squeezing into deep vents or handling wild temperature swings. And you see NASA engineers exploring all sorts of specialized creative designs that ditch the humanoid form entirely. The sources mentioned, for example, tests on a snake-like robot. It's designed specifically to crawl down into tight spots, maybe vents on Saturn's moon Enceladus, or potentially explore Martian ice caps for life signs. Its segmented body, the way it twists and grips. It's perfect for places a two-legged robot would just fall over immediately.
That snake robot is a great example. It's built for the job, not to look familiar. It's probably way more robust, simpler maybe, and can go places Optimus couldn't dream of.
That really sums it up. Forcing the human shape onto the problem actually makes the engineering way harder. So the conclusion seems pretty clear. Unless there's some massive, currently non-existent leap in humanoid reliability, especially in self-repair, an unaccompanied Optimus on Mars just wouldn't last long. It's this grand vision hitting a very hard wall of mechanical reality.
So this whole deep dive, it really exposes that core tension, doesn't it? This incredible ambition colonizing Mars with androids smashing up against today's engineering facts, the fragility of that human-like design and the sheer impossibility of fixing it from millions of miles away.
Yeah, and what really jumps out is how Musk's timelines all hinge on solving something that's just not solved yet. Reliable advanced self-repair. For a Mars robot to work, it's not just about not breaking often. It's that when it does inevitably break, it must have the onboard smarts and tools to figure out the problem and fix itself right then and there, using whatever it has on board or maybe local materials. That needs huge breakthroughs. AI, material science, micromanufacturing, all working together. It's way more than just a software patch.
Which raises that fundamental question for space exploration, doesn't it? Do we prioritize specialized, reliable tools built for the job? Or do we stick with generalized humanoids, maybe because they feel more familiar, even if they're less suited? So what does this mean for you watching this all unfold? Thinking about Optimus's current limits and the potential of things like that snake robot. I'd love to get your thoughts. If you were designing the mission, knowing you couldn't send a human mechanic, what kind of specialized non-humanoid robot would you send? Maybe to explore those Martian ice caps, or drill into a lava tube, or flip it around. What specific tech breakthrough and self-repair, maybe materials that heal themselves, what would actually make Optimus viable for Mars by, say, 2026? Let us know what you think in the comments below. And hey, make sure you subscribe and click that notification bell so you don't miss our next deep dive. We'll see you then.